Hello everyone, welcome back. This is Sundar, and this is gonna be a relatively short video. And in this video, we're gonna be just talking about two main topics, which is motion ratio and how to find and calculate the roll center, and what is the purpose of having a roll center. So let's start with today's short video about motion ratio to begin with. So motion ratio. Before we go to the topic of motion ratio. It's very important for us to know what is a roll and pitch angle. So if you can actually see in this image, so you have three axes, x, y, and z axis, and you also have the rotation along each of these axes, right? So if the car tends to rotate along the x axis, right? If it actually kind of moves from right to left, this is called it as roll angle. Okay, so this movement from right to left of the body, that's called as the roll angle. Okay, and if it actually rotates along the y axis, right, like if it moves from back to forth, this angle, when your body moves, that's a pitch angle. Okay, and if it actually rotates along a vertical axis, wherein it moves, the front side moves right and left a little bit, that's called as a yaw angle. Okay, so again I repeat, the roll angle is gonna be the motion of your car from right to left, and your pitch angle is gonna be the angle which your car body moves from front to rear. Okay, this bouncing motion from front to rear, that's a pitch angle. And yaw angle, it's not that important in a normal passenger car, although you would actually face some kind of a yaw movement in a very high speed supercar or even a formula car. But usually for a normal passenger car or for a competition level car, you wouldn't need to consider the yaw angle. But it's important for us to know what a yaw angle is, but there is nothing much for us to calculate in the yaw angle during the initial stages. Okay, so now once we have learned what a roll and pitch angle is, let's go to the first topic of today, which is motion ratio. Okay, so motion ratio is nothing but how much your spring compresses for each millimeter of your spindle movement. Okay, so if this is your if there is a wheel here, and if it actually goes along a speed breaker, so every 1 millimeter of your wheel movement in the upward direction, how much of the compression is there on the spring. Okay, so that is the motion ratio. So motion ratio is usually it's denoted as how much is the delta spring length, which is the change in the spring. If it compresses, then how much is the compression? So that's a delta that we are looking for for every 1 millimeter of your wheel movement. Okay, so if the wheel moves by 1 millimeter, and if your spring compresses by 0.7 millimeter, then your spring ratio is nothing but 0.7. Okay, but there is another way of actually finding the motion ratio, which is you divide. Okay, you divide the distance from the your pivot point, whatever the length along which your spring is attached. Okay, that distance upon the entire wheel center. Okay, what that distance is, you divide d1 by d2 to get the motion ratio as well. Okay, so how is these two actually one and the same? The reason is, you actually, if you think about it, this is going to be your axis of this is going to be the axis along which your wheel is going to rotate, right? So essentially, if you actually think about it, if this moves by 1 millimeter, this, since it's actually attached closer to the pivot point than the wheel center, this will actually be moving a little bit shorter. Okay, so it's essentially one and the same thing. It's just that where you look that dimension from. Okay, so because d1, and if this compresses, if the wheel moves up, then this compresses a little bit smaller, okay, compared to this. So it's just that instead of calculating the vertical, here you calculate the horizontal distance, but it's one and the same, because essentially whatever the horizontal distance is, that is how much the change is going to be on the vertical axis, because it's one and the same joint. Okay, so it's nothing but just the r theta, or here the theta you can actually consider it as small, so the angle and the vertical is going to be one and the same. So that's the reason why you can actually calculate the motion ratio with either this or that. Most of the OEMs, they use this as one of their pivot points because of the bushing distortions and all of that. So they would actually want you to have an actual compression of the spring to the movement of the wheel. Okay, so this is what the most big OEMs they consider, but this is also not a wrong way of approaching what the motion ratio is. So now coming back to where exactly is this motion ratio gonna be an important part of, right? So in that case, one of the main places where you need to calculate the motion ratio is when you want to calculate what the spring stiffness is. Okay, the spring stiffness is nothing but how much of the force is required to actually compress your spring by 1 millimeter. Okay, so for you to calculate what the spring stiffness is, you need to know how much is going to be the maximum compression on your spring, and where exactly do you need it to transmit that after the compression. Do you want that force to be transmitted back to the body and the wheels, right? So you need to calculate what the spring stiffness is. So for you to know how much the spring stiffness, you need to know what is the motion ratio, so that you can then kind of go do a backward engineering and say that, okay, so now if I want the wheel to go up to go up by 2 inches or 3 inches, then depending on the motion ratio, my spring is probably going to be compressed by I think 2.5 inches. So 2.5 inches is the maximum compression which I want the spring to overcome, and beyond that point, this force is now, this compression is then going to transmit that your wheel going up, transmitting it back to the body, right? So for calculating what the spring stiffness is, you need to know what the motion ratio is. So you need to know where exactly the spring is mounted from either the pivot point, and then ultimately finding what is going to be the compression of the spring compared to the per millimeter movement of the wheel. Okay, so these are the two different methods of actually calculating the motion ratio. Either one is fine, but most of the OEMs, they use the first one. So this kind of gives you an overall overview of how to calculate the motion ratio and why the motion ratio is important. We will be actually getting more into more detail about the motion ratio in our next video, when not the next video but the video after that, when we will be actually going in depth about the major suspension calculations. So we will be calculating the spring stiffness and all of that, where we will be actually making use of motion ratio. But it's important for us to know what a motion ratio is and how can you apply that. Okay, so this kind of encapsulates what a motion ratio is. Now let's come back to the second topic of today's video, which is roll center. So for you to calculate the roll center, if I have to tell you in a very simple way, right? So the step one will be, you actually extend the upper and lower arms so that it intersects somewhere. Okay, and that intersection point is nothing but instantaneous center. So you extend the arms to intersect. Okay, and this intersection point is also called as instantaneous center. So what is the purpose of instantaneous center? So the instantaneous center is nothing but this is the point along which your wheel will be actually moving up and down. Okay, so if you actually see a car moving up and down, it doesn't go vertically up and down, right? It actually follows a curved path, and this is the center along which your wheel will be moving up and down. So it's very important for you to actually finalize these upper and lower arm geometry for you to find the trajectory path of your wheel. It's very important for you to know what is the path that your wheel follows, because so in a competition car, it doesn't matter that much on what path your wheel follows that much, but in a passenger car, this wheel is actually inside the body. It's actually kind of kept enclosed inside the body, right? So when it's actually inside the body packaging, it's very important for you to know what is the path that your wheel follows at all bump and steer conditions, so that it can maintain the minimum clearances with all the surrounding parts around the wheel, because these are one of the critical safety aspects, right? You can't have your wheel interfering when you're driving at 100 kilometers per hour, and suddenly when you're turning, because of the wheel compression and it's moving up, it actually interferes with one of the parts. So that's one of the safety hazard. So it's very important for you to know how to calculate the instantaneous center along which your wheel rotates, and this is exactly how you calculate the instantaneous center along which your wheel will be moving up and down. So once you have found what the instantaneous center is, you actually then connect that instantaneous center to the wheel's center point. Okay, so the wheel vertical axis center point, you connect this line. Okay, and assuming your left and right suspension in the 99.99% case scenario, they are going to be symmetric, right? So symmetric in the sense it's going to be exactly same along this vertical central axis, right? So wherever this line intersects the vertical axis, that is going to be the roll center. Okay, this instantaneous center line, wherever it intersects your vertical axis, that is going to be your roll center. And what is the purpose of roll center? Okay, so now for example, if your CG is going to be somewhere here, assuming that your center of gravity is around here and your roll center is along here, right? So this distance what you have, this is going to be the distance which you want it to maintain as small as possible, because what is rolling motion, as we have seen in today's first slide, is how your car body moves in this direction, right? And your car body moving in this direction depends on what this distance is. Okay, so if you can just imagine that here the CG actually moves right and left during rolling motion. Okay, so it moves right and left during rolling motion, so because of which your body kind of moves right and left, and how much of that movement is going to be depends on this distance, because this is the center, as the name suggests. This is the center along which your body will be rotating. Okay, this is the center, and there is also called as a roll axis, which is just connecting the front roll center, and then you will be calculating the similar roll center for the rear, okay, for the rear axle, and then connect the front and rear axle roll center. That is the axis along which your entire body will be moving, okay, will be actually rotating. So here you can see that the CG is moving right, is actually rotating along this center. And now if you can actually think about it, when you're cornering, as we have established from our previous video, there is going to be a weight transfer from the inner wheel to the outer wheel, right? So if there is a weight transfer from the inner wheel to the outer wheel, this CG, okay, this CG will now be actually moving along this distance, right? Like this is the radius and this is the center along which it will be rotating, right? So if I have to give you a simple equation, this is nothing but the distance is nothing but r times theta, right? The linear distance is nothing but r times theta. So here it's directly proportional to the r. Okay, so theta is a variable which you can't have much control just with the pure roll center. There are multiple ways of controlling the theta as well, but one of the things variable which you have a control with just these upper and lower arm positions is this roll center. So you can actually control what this r is. Okay, what is this distance, and with that distance, if you reduce this distance, your movement, okay, will also be minimized, because essentially this movement is nothing but r times theta. Okay, so your linear movement of your body will also be reduced, and in most of the F1 cars they have this distance much close to each other. That's the reason you don't see that rolling motion that much on an F1 car, because they can't afford to have a rolling motion, because of which there is a contact patch. Okay, there is an inside contact patch that actually loses a contact at a very high speed, so they can't afford to have that. So they actually try to maintain this distance as low as possible. Okay, and if you can actually remember, in the first video I showed you this video, right? Like how can you actually control the best suspension system, right? And this was about the soft and the hard suspension, right? But now look at this video again concentrate on the left side video with purely rolling motion that happens on the car when it tries to turn. So you can actually see the body is actually moving. You can see the body is kind of tilting and it's moving along that imaginary axis, right? That motion is what we call it as rolling motion. And now if you see on the right hand side, there is no compression. Okay, so there is no movement of the body when it turns compared to the right hand side, compared to the left hand side. So this doesn't have a rolling motion on the car, but this has a rolling motion. That theta change, the body compression that you can see, that is what we call it as a rolling motion. So this concludes our second video, so the first part of our second video, where we learned the different motion, where pitch motion and your rolling motion, and how you what axis these motions actually rotate. And then we learned about the motion ratio and how to calculate the motion ratio, and how to what is the purpose of a motion ratio in knowing the stiffness of the spring. And then from there we actually learned on how to calculate, how to actually find the roll center, what is the purpose of the roll center, okay, and what for the best motion, okay, for the best design to actually avoid a rolling motion, how are you supposed to tune your upper and lower arms. Okay, so with this we conclude that. So stay safe and thank you for listening, and let me know if you have any questions. Thank you.